Today we're going to be talking about graphing a function rule. We're looking at what goes into it and some things that may change when we do graph it. So to start off with, we're going to look at a function right here. When we have a function, we have what we call inputs, what we start with, and outputs, what we end with. And what we do, we can pick any x values we want that work, plug them into our function, and we'll get something out of them. Sometimes we set up a longer chart like this, where it kind of shows what our work's doing to help us get the right answer. Now, I chose to use the numbers for my inputs as -1, 0, 1, and 2. So we want to solve that. We're plugging and chugging, plugging the numbers in to get our answer. And this is how it looks. The 3 stays the same, the -4 stays the same. The only thing that's changing is this x value that we're replacing with our input values. And as you can see, we do 3 times -1 minus 4. It's -7, -4, -1, and then a +2 when we work them out. Now if we want to do a shortened down form, which eventually we get to, just to save some time, we're going to represent it like this. And we have this now chart that we can complete. Now if we're looking to graph this, sometimes you have graph paper, sometimes you don't. Most of the function we're looking at now are going to be lines. So with this, when we have these relations of numbers, we can also represent them as an ordered pair. -1 goes to -7. So -1 to the left, down 7. So it's going to be about there. 0, -4. Now we have 1, which will go to the right, down 1, which is -1, and then 2, 2. We can see that this is going to form a line. Okay. If we look at the second one, we plug in the numbers as we go. You can plug them in here, but for the sake of time, I'm going to walk through these. -2 times -2 is 4. 4 plus 8 is 12. This ends up being, or substitute -1 in, 2 plus 8 is 10. When I plug 0 in, again, start using 0 all the time because it's easy. Because anything times 0 is 0, and it's just that last number, 8. And then -2 times 1 is -2, plus 8 is 6. Now at this line, again, we're going to start at -2, and we have to go up to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're way up here on our graph. -1, 10, 0, 8, and then finally 1, 6. And you can see that this also makes a line coming down. When we plot these points, they should be in a straight line. So all these functions we're talking about are linear. If you get something that's curving one way or the other, we probably messed up somewhere. So go back and double check it. Now on these problems, I want you to start looking at patterns. There's a correlation between the numbers up here and the numbers here. So if you look, our x values in each of them are all increasing by 1. We did that for a purpose. If these are all increasing by the same amount, these should be all changing by the same amount. -3, -3, -3. In this function, I'm sorry, +3. What am I saying? Here, -2, -2, -2. We have a pattern there. If you notice, we talked about patterns the last few sections. See these +3s? It's a +3. Look at our function. Our 3's there. That is not coincidence. That should happen every single time. If we look at this one, -2, Look what the number is multiplying by x, a negative 2. So we can start identifying these patterns. And the more complicated functions that we see, you'll start seeing other patterns as well. So we're going to look at this word problem. So we're going to see a lot of word problems, a lot of real life scenarios. They're going to involve functions. So it gives us our function rule. W, which represents the total weight in pounds, and C, the amount of concrete or the capacity of the truck that we can carry inside this concrete truck. So we start off with this equation, and it says the capacity of the truck is about 200 feet cubed. What is a reasonable graph of the function rule? What are the possible input values that can be used? So let's think about this. We start wanting to think about minimums and maximums. What would be the minimum amount we want to use? Well, what is the minimum amount we can put in our truck? The amount of concrete. It is 0. We can't put anything less than 0, and we can't put in a negative amount. The maximum value is 200 cubic feet. So everything in here between the x's, between 0 and 200, is a possible x value we can use, or a possible c value in this case. That's our input. So when we put this in, it says when our truck is empty, 146 times 0 plus 30,000 pounds. So our truck weighs 30,000 pounds. If we want to know how much weight there is if there's, say, 100 pounds in our truck, we would go 146 times 100 and then add it to the 30,000, which would be 44,600. If we put 200 in there, so what do we got? It comes out to 59,200. We could put any other number in there to show what our graph is going to look like. Now, when we're making this graph, I like to think about when we're creating our own graphs, like you're creating a picture for your art teacher. She gives you a big canvas. You're not just going to use a little part of it. You want to make sure you're showing and trying to utilize as much of that canvas as possible. So we have to think about intervals for our x values and intervals for our y values. They can be anything you want, but you want them to stretch out to fill in the whole area. So the x value is our how much concrete we can have, which goes on the bottom. We're going to go from 0, and maybe we go up by 50s. Okay? And I'm kind of cutting a little short. But with the weight, I'm going to start here at about 0, and I'm going to go up by tens of thousands. 10,000, 20,000, 30,000 pounds. 40,000, 50,000, 60,000 pounds is there. So again, if our x value is 0, we are at 30,000 pounds. If it's at 100, I'm at about 44,600. I'm kind of guessing where it's at. And then at 200, we're at 59,200, just under 6. Now we can include any amount of concrete here. So we can connect it with a line. But it can't go past 200. So if we try to put more than 200 cubic feet in, our concrete truck's going to start overflowing. So our graph in this case is kind of limited between 0 and 200, and from 30,000 pounds up to 59,200. So we're plugging numbers in to see what the weight of our truck is. And in real life, a truck driver